Some of the solutions, more solutions to resolving control valve leakage besides having an isolation valve upstream, that we mentioned earlier that the conventional positioner that is used on a control valve potentially can actually worsen the leakage from class 4 to class 3. There also is actually another factor here that conventional positioners constantly need calibration, and the zero setting of those, which is the closed position typically, will drift. And in many cases, after several months or up to a year certainly, the zero position could drift to 2 to 3% open of the valve. So when you're in the control room, you think your valve is in a closed position. The reality is it could be actually 2 to 3% open, and you don't even know it. So one of the solutions that a lot of people are going to these days, and it's a well-proven technology now, is called a smart positioner. Smart positioners have microprocessors on board, and all the key manufacturers make them: Fisher, Mason-Nealon, Warren, and all the good, Leslie, all the good control valve manufacturers have them. And what it has what's called a tight shut-off feature. And we mentioned earlier about potentially you could have air pressure in the bottom side of that actuator still pushing up against the spring because it's in a balanced position. Well, when you program the smart positioner, they will evacuate all that air out of there, guaranteeing that you have full spring thrust pushing down, which will help shut off your valve. Also, one of the real pluses of having a smart positioner, you can see this chart out to the right here. The black line actually is the control signal going to that control valve. The blue line is the actual valve position. And you can see that they follow extremely closely to the control signal. And with this definitely will save you energy. From the standpoint, you won't be overshooting set points. The valve will not be oscillating back and forth. This is a real technology breakthrough in the control valve industry, and smart positioners have been well accepted through almost all the different vertical markets. Okay, this next slide is, I think, pretty interesting. I read an article in Valve Magazine somewhat recently about control valve leakage. And interesting enough, the result of their studies found that many times the smoking gun was not the control valve, it was actually the bypass valve. And a lot of control valve applications, for different safety reasons or whatever, a bypass is installed in case the control valve has to be taken offline so they can still get flow through there. And that is kind of the forgotten step in this, and many times that bypass valve doesn't get operated for potentially years. And anyway, they found out that a lot of leakage was happening on those valves, and nobody was paying attention to them, and they thought the control valves were leaking. So this is just something else to think about. It's just another place where potentially energy could be lost. And so, okay, one of the second topic on our program agenda is called automatic boiler blowdown energy savings. First of all, I'm going to give a definition of what boiler blowdown is. Boiler blowdown is the removal of water from a boiler near the top surface of the drum level, which is, as you can see my pointer, it's right here at the top level of the drum. Its purpose is to control the boiler water quality and to minimize scale and corrosion. Boiler blowdown is also used to remove suspended solids present in the system, and these solids actually are just caused by feedwater contaminations from various sources. I'm not going to go into a lot of details, but it is an important step in creating steam in your boiler, and this can save you a lot of money if you have a good system here. So in effect, some of the boiler water is actually removed and replaced with feed water, so that's what boiler blowdown is. And the amount of blowdown can actually range from less than 1% if you have extremely high quality feed water to greater than 20% if you actually have a poor feed water system. If you were to install a proper boiler blowdown system, you would minimize energy loss and actually save about 2% of your facility's total energy use with an average payback of less than 1 year. That in alone, I think, should interest you in possibly looking at something like this. Excessive blowdown wastes energy in a variety of ways. You actually wasting water, which you just went through the trouble to heat it up, to put it into the boiler, and also treat it and clean it, and try to get it as high quality as you can, and get your yanking it off because you're trying to get the impurities off the top of the boiler drum. And also, there's a lot of very expensive water treatment chemicals that are in that feed water. So there's multiple savings to be had there. If you can create the optimum blowdown, to do that, you need to measure the conductivity of the boiler feed water. Conductivity is probably the simplest and most widely used indicator of the overall total dissolved solids that is in your feed water or in your drum level. This next slide shows you if you would install an automatic boiler blowdown savings, some of the or blowdown system. This is some of the savings you actually would encounter if you were to reduce your blowdown by 2,000 pounds per hour. You can see the fuel dollars and the water treatment dollars. You're looking at some substantial savings there, and I think that. And by the way, just to go back. Typical ways that the boiler blowdown is done, it usually is done manually many times, and it can either be a sequential thing where you actually open it up every once in a while. You could do it every hour or every 2 hours or whatever. And then a lot of situations you actually install or just have a valve that is called a continuous blowdown, where it is cracked open at a certain percent, and you pre-calculated how much you think needs to come off of the boiler drum. And but again, those are not the best ways to actually try to control your boiler quality of water. This first slide will give you an example of you have a set point of how good the quality of water you'd like to have, and wait for the slide to come through. And the red line actually indicates, if you were doing this manually, how much control you actually would have over that. And you see, it's very hard to control that. You have a big sawtooth curve there, and you're definitely not in control at that point if you're trying to do it manually. If you were to install an automatic boiler blowdown system, the green part of the graph here indicates where you would be. Now, even though it's not right on the line, this is a tough thing to do to try to maintain this, but this certainly is a huge improvement and a big energy savings over trying to do this manually. All right, a lot of you might ask, well, how exactly does this work? Well, I mentioned earlier that you need a conductivity sensors and a conductivity controller. And the photograph to the left there is actually a package system, but you can do it a lot of different ways. You can actually just do it yourself and set up different components. But the bottom line is you need the conductivity sensors. You need the conductivity controller that actually can look at that. And it's programmed. In this case, this one is programmed to take samples on a timed basis, and that could be literally every 15 minutes, or it could be every hour. Or again, you need to determine that based off the quality of your feed water. It's very important that the sample be cooled. This particular system is set up and designed that it will cool the sample. The quality of the reading of the conductivity is better when the water is cooled. So you compare the conductivity rating to your set point, and then the controller sends a signal out to the control valve to remove water from the steam drum surface. And again, I mentioned earlier that the reason you want it removed from the surface is that's where the highest level of solids, dissolved solids, are located at. By the way, we can help you with designing a system like that and bringing in some experts if you have some interest like that. Okay, the next item on our agenda is, are your valves really closed? I know, again, that sounds like a absolutely silly question, but if you have the typical manual gate valves or globe valves, if you're just standing there looking at them, sometimes it's very difficult if they don't have the stem, a rising stem where you can actually tell what's going on with them. It's very difficult to look at them and know if your valve is fully open and closed. And also multi-turn valves such as the gate valve or globe valve there to the right, they tend to bind up, especially if they've been in an open or closed position for any period of time. And many times the operator goes up and grabs that handle and tries to turn it, and it gives a false feel that maybe the valve might be closed because it becomes bound up. And an over-tightening of the packing gland can seize the valve, sometimes just the stiction of it being in one position for a long period of time. So in some cases, it's a little bit dangerous for these manual valves to, like I said, you go up there, you turn it, and you think, I can't turn the thing, so you might think the valve is closed, and the reality is it's not. So for some of the answers to what can we do to verify if your valves are closed, like a gate valve or a globe valve, would be to automate those. And typically these large multi-turn valves are done with electric motors, either limit torque or row torque or EIM or all the big manufacturers of those. And there's no question that initially the costs are substantial in automating those. You're going to get into the thousands of dollars very quickly when you start putting a multi-turn motor actuator on these valves. But the payback is what you really have to look at, and what you're controlling your valves and actually managing them properly. First of all, you can give a remote signal to open and close these valves, so you don't have to send that person out there to try to turn that handle and see if the valve's open or closed or not. And you also get an electronic confirmation signal back in the control room of what position that valve is in, whether it's at mid-stroke or full open or full closed. Also, I think one of the pluses of the multi-turn electric actuators is that they use torque switches actually to determine their closed position, which means they're driving the plug of the disc into the seat, and they drive it into a pre-programmed torque area, and before that motor shuts off. So in my mind, you're getting the best of both worlds, where you're getting a good tight push into the seat with those torque switches determining that. And also, lastly, an automated valve will last longer just due to the fact that it's not left in what's called a near-closed position. We mentioned earlier in the control valve leakage, if the valve is partially still open, the velocities that go through those chambers there, when they're just barely cracked open, they do a lot of damage to the valve, and they will prematurely age the valve, and the valve will wear out a lot sooner than normal.